So continuation of this paper 4 variant 1 May June 2016. So explain in terms of molecule why it is not possible to compress a gas. It's possible to compress a gas but not a liquid, because what happen in liquid, the particles are very close to each other. In liquid, the particles are close to each other, whereas in gases the particles are far apart from each other or far away from each other. That's why, like, we compressing means like applying a force, reducing a volume. So in gases, the particles are already, they're far apart from each other, so we can bring them closer. We can reduce the volume or we can bring them closer. But why liquids cannot be compressed? Because the particles are almost like touching each other or very close to each other. That's why it is difficult to compress a liquid as compared to that of a gas. Then two containers which are made of insulating material. Insulating material means a material which does not allow the heat energy to pass. This contain a same volume of water at room temperature. The containers do not have lid. The volume of the liquid in each container gradually decreases. After a certain time, the temperature of the water has decreased below the room temperature. Explain in terms of molecule why the temperature has decreased. So basically, due to the evaporation, the most energetic molecules, so example, we have a container and that container is filled with a liquid, and there are particles of the liquid, and these particles of the liquid, some particles are there at the surface. So there are most energetic molecules, particle which are there at the surface, they gain energy from the surrounding. So when the most energetic molecules or particles at the surface gain energy or take energy from their neighbors, they can go out. As a result, when they will go out, the particles which are left behind, they are left with low energy. So in terms of molecule, we have to explain. So what happened? The most energetic molecules at the surface gain energy from the neighbors or from the surrounding, and they leave the surface. As a result, when the molecules which are left behind, they have low energy. That's how it causes a cooling effect. Evaporation is also known as the cooling process. So the most energetic molecules escape from the surface, left behind molecules of low energy which cool down the liquid. So whenever evaporation happen or occur, it is always a cooling process. Then one of the container is wide and shallow. So one of the container is wide and shallow, and the other container is narrow and deep. So these are the two containers, but they have the same amount of liquid. Predict which container will have a greater rate of cooling or which container will cool down faster. So the container which is wide and shallow will cool down, liquid cool down faster as compared to a container which is narrow and deep. The reason is that because in a wide and shallow, there are more particles are there at the surface exposed. Here few particles at the surface are exposed. So yeah, that's right, you can mention a surface area. So you can mention the one which is wider or the large surface area. The rate of evaporation will be faster because there is a greater chance for the molecule to escape. So wide and shallow, because large area, So more chance is there for molecules to escape. In question 5, state what happened to molecule of a gas in a sealed container. When they use the term sealed container, it means the gas cannot escape. That's the meaning of sealed container. When the temperature of the gas increases or increased. So it's a sealed container. It means the container is fixed. It does not allow the gas to escape. The volume will remain constant. So if the volume remain constant and we supply the heat energy, so as a result, when we supply the heat energy, the molecules will move faster and they will exert more force on the walls, or they will collide with the wall much harder. So you can mention it will increase the kinetic energy or speed of the molecule increase, or you can also mention they will collide often with a wall. Then a quantity of a gas is contained in a sealed container of a fixed volume. The temperature of a gas is increased. State in terms of molecule two reason why the pressure of the gas increases. So when we increase the temperature, why the pressure exerted by the gas is increasing. We already mentioned one of them, like in the beginning we mentioned it is a similar answer. Speed increases. So if you mention speed increases, so here we can mention there will be more collisions. So it will have more collisions with a wall, or frequent collision, or much harder collisions will be there, or collide with a more force. Number of the collision increase, that's one thing, and it will collide with a more force, that is another thing. Like how many times it collide, that is the number of the collision, and the force which it will apply during a collision, that's a force of the collision. So increasing a temperature increases both of the factors, number of the collision as well as the force in the collision. Then we have a helium filled weather balloon which is held on the ground. The volume of the balloon is 4,800 meter cube. So there's a balloon which is held on the ground. Say the black line is representing the ground. So the ground level is represented, say, by this black line. The pressure is 98,000 Pascal or 98 kilopascal. So here we know the volume. The first volume is 4,800 meter cube, and the first pressure on or by, because the outside and inside pressure is same. Otherwise, if outside pressure is more, then the balloon size should decrease, and then if inside pressure is more, the balloon will explode. So we consider that it is balanced. So it is 98 kilopascal or 98,000 pascal. The balloon rises, but the balloon is released and rises to a height where the volume of the balloon is 7,200, because the pressure decreases from outside, so the volume increases. So the new volume of the balloon as it rises, it is 7,200 meter cube, that is V2. We want what is the pressure, because if outside pressure changes, inside pressure will also change. As the size is increased, the inside and outside pressure will be balanced. So calculate the new pressure of helium. So whenever and what we assume here, we assume that the temperature does not change, because if the temperature change, we cannot use the formula P1 V1 equals P2 V2. So P1 is the first pressure. If I take 98, so if I take 98 only, no, I did not convert into Pascal, kilopascal into Pascal. So my final answer should also be in kilopascal. So 98 kilopascal, I'm taking 98, then 4,800. Second pressure we don't know, and the second volume is 7,200. This is multiplied, other side it will be divided, so it will be 98 times 4,200, 4,800 divided by 7,200. So this will give us the pressure as the balloon rises to the higher altitude. So it will be about 65 kilopascal, kPa, or 65,000 Pascal, and suggests why it may be necessary to release the helium from the balloon as it rises even higher. Why we should release some of the helium as the balloon is rising higher? Because what will happen, as I mentioned in the beginning, if the inside pressure is more, if the pressure from inside is more than the pressure from outside, the balloon will explode. So as we move to higher altitude, as we go above our atmosphere, so the pressure of the atmosphere, because on the surface of the earth more air particles, but the density of the air, it is decreasing, the atmosphere get thinner as we move at a higher altitude. So atmosphere is much thinner. So if the balloon is at this point, like at this height, and balloon is filled with the helium gas, so why we should release some of the helium out from the balloon as it reaches the higher altitude? Because what might happen, because outside pressure is too low, outside pressure is pressure due to the atmosphere. So if the outside pressure is too low and inside there's a helium gas which is exerting more pressure, then what might happen? The balloon might burst. So just to protect this balloon from bursting, we should release some of the helium out from the balloon. So preventing the balloon from bursting, we should release some of the helium. In question 6, two students measuring the speed of a sound. This is the same thing we discussed yesterday, that students are provided with a starting pistol, a long measuring tape. When fired, produce both sound and a puff of smoke. Describe how student uses the apparatus and how to calculate speed. You may draw a diagram. So this is the same experiment which we used yesterday. We discussed yesterday how to find speed of sound in air. So two, two people can perform this experiment. A person at position A, he fires a shell, and the person at position at B, so measuring the speed of a sound in air. This is the whole experiment which you have to write. A person is at position A. When he fires the shell, two things will happen: light and sound, both will produce at the same time. So when an observer at B, he will see the flash, he will start the timer. When he hears the bang, he will stop the timer. That is the time taken by sound to reach from observer A to observer B. And they can measure the distance by using a measuring tape or a treadle wheel. And using a formula, speed is distance divided by time, we can find the speed of sound in air. And for accuracy, repeat the experiment by changing the distance, or repeat the experiment by changing the position of, or switching the position for observer A and observer B. So this is a whole experiment. As I mentioned, you have to write. You can write in your own words, but you should have these points in your mind when you're writing the answer. So this is the same, the whole is the same experiment which you have to write. And you may draw a diagram. So you can, to explain your answer, you can draw a diagram as well. Then in part B, a device at the bottom of a sea emits a sound wave of a frequency 200 hertz. So frequency is 200 hertz. The speed of the sound in a sea is 1500. So that is the speed. We need the wavelength. So formula V equals F lambda. That is valid for all kind of waves, for light waves or sound waves. We can use this formula V equal F lambda for any kind of wave. The frequency is given, the speed is given. We just need the wavelength. So we substitute the value. The speed is 1500, frequency is 200, and wavelength we don't know. So 1500 divided by 200. So 200, when we solve this, it will come out as 7.5, and SI unit of length is meter. So wavelength is also meter. In second part, the speed of a sound wave, the sound wave when it passes through from sea water into air. So sound wave is in a sea water. In sea water, the sound wave travel at 1500 meter per second. But then in air, when it moves, it travels 330 or 340 or even 300 is correct. What happened to frequency? The frequency of the wave never changes. Remember, any kind of wave is there. When it travels from one medium to another, frequency never changes. It remains constant. But what happened to speed? That is moved from seawater to air. What we observe, the speed will decrease, because in seawater it can travel at a speed of 1500, but in air it can only travel around 330 or 300 meter per second. Then in question 7, a ray of a light passes through a length of a curved optical fiber or fiber optic. Draw a diagram to show a fiber and the path of the ray. So we have to draw a fiber, optical fiber or fiber optic. You can draw any curved surface. But when you show the reflection, don't show many reflection, only 2 or maximum 3 is enough. That's it. So this is a label. Whenever you draw the diagram, it should always be labeled. So this is optical fiber or fiber optic, and this one is a light. Describe one use of optical fiber in medicine. You may draw a diagram. So how we can use optical fiber in medicine? We can use in endoscopy, and see the weightage of the question. It is of 3 marks. So we can use endoscopy to examine the internal parts of the body or to examine the internal body. And how it works, the bundle of optical fiber is used and light will undergo total internal reflection and go in and out of the body through optical fiber. So here when we write the answer, we'll mention we can use in endoscopy to examine the internal organ, and how it works, the light will undergo total internal reflection and it goes in and out through optical fiber. So these are the points you can mention. So it is used to examine the internal organ, or we light travel through optical fiber, undergo total internal reflection. And you can draw a diagram. You may draw a diagram. It's better you draw a simple or rough diagram just to represent the optical fiber. And you can draw a stomach or a windpipe or esophagus that the light is passing through. Is it clear that how endoscopy works?
Yes, sir.
So in this part, draw straight lines from each wave to the left to the most appropriate speed. Light in air. What is the speed of light? Light is electromagnetic radiation. So all the electromagnetic radiation travel at a 3 to 10 power 8 meter per second. Microwaves are also electromagnetic radiation. So they also travel 3 into 10 power 8 meter per second. And sound in a steel, so basically it's like a sound in solid. Steel is a solid, so it's about 5,000, 4,000, any range in this range. So speed of sound in steel, which is a solid, so it is 6,000 meter per second. Then refractive index of a block is 1.5. Calculate the speed of a light in a block. The formula which relate the refractive index and the speed, that the refractive index is equals to speed in air or vacuum divided by speed in a medium. Here speed in medium is a block, so we can say speed in a block. This refractive index is speed of light in air, which is fixed 3 into 10 power 8. Refractive index in the question is given 1.5. The speed of light in air is 3 into 10 power 8, and we don't know the speed in block. So we cross multiply, V will be there in numerator and 1.5 there in denominator. So about 3 exponent 8 meter per second divided by 1.5. So we'll get this as 2 into 10 power 8 meter per second. So this is a speed at which the light will travel in a block. So when light move from, remember one thing, when light move from vacuum to a material, the speed of light decreases. But for sound, when it travels from low density to high density medium, speed of the sound increases. So this was the last question related to weekly homework from May-June 2016, paper 4, variant 1.